Okay, let's dive in. Welcome, everyone, to the deep dive. Today, we're looking at something pretty specific based on the sources you shared with us. It's about maths, but, out there in the real world, we're connecting calculus differentiation specifically to, well, forestry.
That's right. And it's really interesting how these sources show these, well, sometimes abstract seeming math ideas become these incredibly practical tools, for understanding and actually managing real world things like forests.
Exactly. And the sources really zero in on one particular area within forestry, forest fires.
hmm
They're showing how differentiation helps understand how fast a fire spreads, and crucially, how that speed links up with the wind.
Yeah, that wind factor is key in the material. And it makes sense, right? Managing forest fires is, it's vital work, huge impact on safety, ecosystems, everything. And the challenge, as the sources point out, is that wildfire behavior isn't, simple or static. The speed changes. Wind is a big driver.
So this is where calculus steps in, differentiation.
Uh-huh. That's what the sources are getting at. Differentiation is basically the mathematical tool for measuring change, how fast something is changing.
Okay.
So fire spread speed changes when the wind speed changes. Differentiation lets foresters, fire analysts, figure out how sensitive the fire spread is to a shift in the wind, like right now.
Okay. So it's not just knowing, oh, more wind, faster fire, which I guess feels intuitive.
Right.
The sources suggest differentiation gives them a number, a specific measure of that sensitivity.
Exactly. Think of the fire speed as being a function of the wind speed. It depends on it. Differentiation calculates the slope of that relationship at any point.
The slope,
Yeah.
how steep the change is.
Precisely. That slope tells you, okay, if the wind picks up just a little bit, how much faster specifically is this fire likely to move?
Hmm.
It quantifies the relationship.
Right. Okay. That makes sense. That must be, well, pretty critical for trying to predict what happens next, for making decisions.
Absolutely critical. Knowing that rate of change, it informs huge decisions. Think about safety zones or when to tell people to evacuate or where to send fire crews. If you know how quickly the fire accelerates when the wind gusts,
Yeah, it changes everything.
it gives you a much more fine-grained understanding than just wind makes it worse. The sources really hammer home that practical side.
So it seems like differentiation is a key piece for modeling fire behavior, specifically because of that wind connection highlighted in the sources.
It is. The focus in your material is clearly on using differentiation to analyze that rate, how quickly fire spread changes relative to wind speed changes. Yeah. That's the core mathematical insight being applied.
Okay. So, wrapping up this deep dive then, the main takeaway from these sources seems to be this specific use case: differentiation in forestry. Using it as a really precise tool to analyze just how sensitive forest fire spread speed is to changes in the wind, calculating that